on TV?
You're on TV.
That's incredible.
What's incredible is how he started from cleaning toilets in school to making trillions of dollars. Meet Jensen Huang, guy who founded Nvidia with just $200 in his pocket and turned it into biggest company of the world. Company that is so big, if it was a country, it would have the 7th biggest economy in the world, leaving behind countries like Russia, Mexico, and France. But how did all of this start? What does video games have anything to do with artificial intelligence? Why would US government build a supercomputer with PlayStation 3? This is the story of Jensen Huang. Jensen was born in Tainan, Taiwan in 1963, but his journey starts when he was 5. And let me tell you how I actually mean journey. Huang family moved to Thailand in 1968 in hopes for a better future, but Thailand was about to change.
There was an upheaval. Military was tanks and soldiers were marching down the middle of the street. People were shooting each other. And so my parents felt that it was probably best to send us to the United States to live with our uncle.
But Jensen had to move again soon. His fourth stop was Oneida Baptist Institute in Kentucky. His uncle sent him there thinking it was a prestigious boarding school, what turns out to be a very harsh environment.
Oneida Baptist Institute turns out to have been quite a special school, and I knew something was wrong when we checked in.
See, Oneida Baptist Institute was founded with the intent of ending cultural feuds and violence in Clay County. Aim was to teach children of the hostile clans to love each other and not to fight. They thought they could solve the violence and bad blood that terrorized the region since 1899. When Jensen walked into school for the first time, he saw the school ground was covered in cigarette butts. After settling into his room, his roommate, which was 17 at the time, returned from the hospital with 7 stab wounds after a fight which the other kid passed away. Seemed like Jensen, no matter where he goes, couldn't escape the violence, so he learned how to live with it. He made a deal with his roommate. In exchange of teaching him how to read, he was going to teach Jensen how to bench press. In this school, every student also had to work after classes, and that's where Jensen started cleaning the toilets. But after a couple of years, his parents moved to the United States, and Jensen went to live with them at Aloha, Oregon. This would conclude his journey for the time being. Next time Jensen started moving around the world, he would be meeting with presidents and prime ministers to talk how AI will change the world as we know it. Jensen was performing so well in high school, he managed to skip 2 years. He was only 16 when he graduated from Aloha High School. Later on, he got admitted to Oregon State University to study electrical engineering. In his first year, Jensen fell in love with his lab partner, Lori Mills. As a 17-year-old, he was the youngest person in the class, and he knew if he wanted to have a chance with Lori, he needed to use a strong suit, which was being smarter than everybody in the room.
And so I walked up to her and I said, "Do you want to see my homework?"
Jensen also found himself a part-time job at Denny's. He started as a dishwasher and moved up to being a busboy, then started waiting tables. But he quit Denny's at the last year of his education and started focusing on his future career, which landed him a job at LSI Logic. He finally stepped into Silicon Valley, where one day he would be the biggest in. LSI at the time was a pioneer in developing custom-made computer chips. Jensen's department was responsible for creating new platforms and interfaces for these custom-made chips. Later on, he moved on to AMD as a microprocessor designer. These two companies and the experience he gained was so valuable, it sparked the idea of his biggest invention. During his early career, Jensen and his 2 other colleagues, Chris and Curtis, would regularly meet at the Denny's at East San Jose to discuss what they could do in the future. Jensen already learned how to design a chip and how to create a platform or interface that required to make the chip operate the way he wanted. In 1993, Trio decided that they wanted to make their own microchips, focusing on computer graphics. With help with a business plan, which still hasn't been completed till this day, a name that would shape the future of the world, they started their first company, Envision. Well, just like the business plan, Envision had to change too because the brand name was already in use by a toilet paper manufacturer. So they have decided to change the name to Nvidia. Now they were ready to change the world. But how do you do that exactly? This is a question that many creative minds come across when they decide to start taking action in the business field. How do you build a company? What paperwork will you need? Where do you apply? How do you hire people? How to handle their payments? What about taxes? See, building something that you already know is easy. Real challenge comes from the things you don't know. Drowned between all these questions, Jensen decided to get some help. In April 1993, he found himself a lawyer that can help with all the legal aspects of the work so he could focus on what he knows best. Lawyer's first advice was to evaluate the company to make it into a corporation. He asked Jensen, how much money do you have in your pocket? Jensen had $200 at the time, so he bought 1/3 of Nvidia on the spot, which brought up company's worth total of $600. That 1/3 portion of Nvidia is now worth more than $1 trillion, but at the time it probably didn't even worth 200. To add value, Jensen needed to create something, and that's what he did. 24 months after the company's initiation, Nvidia announced its first graphics chip. Expectations were high. Besides the 3D graphics processing capabilities, it also had 2 different sound cards and 2 different joypad ports that made it compatible with Sega's gaming console Saturn and the current IBM computers. But having all that functionality on a single small chip led to significant compromises, and NV1 failed bad. Out of 250,000 pre-ordered products, 249,000 was returned, and retail sales were going just as bad. Jensen's description of NV1 was, it was a great technology achievement, but it was a terrible product. On the surface, reason behind the NV1's failure looked like it wasn't the product that market needed. What market needed was a graphics chip that works, and they wanted as cheap as they could get. But the real reason behind the failure was the product that Jensen Huang was trying to create, which is the modern graphics cards that we have today that can process and simulate more information than computers' central processing unit. Also, there was nothing to compare with NV1.
And so your PC companies are trying to figure out, okay, so this NV1, you can't compare it to anything, but it's not as good as this thing at this. It's not as good as that thing at that, but it's incredibly good together. It's really hard to buy things like that. Nobody goes to the store to buy a Swiss Army knife, and it's something you get for Christmas.
But Nvidia had a second chance. This time, Sequoia Capital, first investor of Nvidia who provided the research and development expenses, was out. But now, there was even a bigger player who was fascinated by the potential of NV1 and wanted to invest in them. Sega was dominating the video game industry with games like Virtua Fighter and Daytona at the time, and they were in the market for a new partner in graphics technologies. Nvidia got the deal, and they started developing the new gaming console for Sega for a $5 million contract. But there was another problem on the horizon. Nvidia's chips architectures was supporting quadrangle rendering. Let me tell you what it means for a second. When you're playing a game, CD or the game files that are saved in your hard drive are sending codes to your computer or console. Codes look like this, and they're basically coordinates for your computer to recreate the image on your screen. So your computer will take these coordinates and connect them to each other and recreate the surface. Then the color codes will be transferred to tell which pixel on the screen should be in which color, and that will conclude the rendering process. Nowadays, games are rendered in triangles because triangles allow computers to render flat surfaces, which is the easiest way to start recreating a 3-dimensional image with just 3 coordinations in every line of code. Problem for the Nvidia's new chip NV2, just like NV1, was the quadrangle rendering, which means computer has to process 4 different coordinates in every line. I know it doesn't sound like much first, but the problem is what 4 dots in a 3-dimensional space can turn into. 4 different coordinates do not always shape a square, but it also can shape a 3-dimensional object like pyramid, and that would require much more computing power than a flat surface. So much so that the graphics chip can't even be called chip and should become another unit called graphics card. Now I know, it sounds like Jensen is about to invent the modern graphics card, but the problem he had at the time was the time itself. While Nvidia was trying to create NV1 and NV2, everybody realized that the computer graphics industry was growing and competition started to emerge.
This is 1995. Microsoft had come out with Windows 95, and the API called DirectX is the architecture that everybody else uses except us. We had never even implemented a graphics architecture like DirectX before.
Jensen realized that quadrangles were not way to go, but there was no solution. Either he was going to push Nvidia to finish the game console with Sega to fulfill their contract, which meant spending 2 years on a wrong architecture and losing the race in an industry that they have started, or he was not going to fulfill the contract, which meant running out of money and immediate bankruptcy. Jensen knew they should start from scratch to adopt the triangle rendering, or what is known as texture mapping. So he decided to try the impossible so that Nvidia could survive. He arranged a meeting with Sega's CEO at the time. He explained to him that Nvidia was in the wrong, and if they would fulfill the contract, Sega would be investing in the wrong technology and Nvidia would be out of business by the end. When CEO asked Jensen what he was asking him to do, Jensen asked for the impossible.
I told him that although there's no reason for him to do this, I would like him to let us off of our contract
relieve us of our responsibility of fulfilling the contract, but pay us in full.
Even though that Sega had nothing to gain from this proposition, they have accepted to pay $5 million to Nvidia, which gave them enough time to work on a new chip. But there was another problem. When creating a new chip, you build it first, write a software for it, find the bugs in a system, and iterate the chip, and tape it out again and again until you get one that works without any issues. This process would take at least 18 months, but they didn't have time to tape out more than one time. Their financial position allowed them to build the chip once and for all. If not, Nvidia would be out of business. This was the time for Jensen to show his quality as a CEO. So he found a way to work on the chip without taping out anything. He found a company called ICOS that making emulators. These refrigerator-sized machines would allow you to program and emulate computers. So Jensen thought if they could have get their hands on one, they could program it to emulate computer and the chip, so they would start writing the software before they tape out anything. But when he tried to contact them, he found out that ICOS just went out of business. When he explained them his situation, he managed to buy one from their old inventory, so they started working. After testing everything, Nvidia taped out NV3, or as the market knows, Riva 128, and it worked. Matter of fact, it worked so well, it sold 1 million units in just 4 months. Also, emulating the chip before taping it out gave Nvidia such an edge on production timeline. They've not only closed the gap with the competition, but in 1999, Jensen and Nvidia changed the gaming once and for all. When GeForce 256 came out in 1999, whole industry changed. But what made it so special? Well, it was the first example of graphics processing unit, meaning that it was the first graphics card as we know it. It was not a chip anymore, and it worked as an accelerator for the computer, meaning that whenever a computer struggles with a hard task, GPU would help with the task and made it get done a lot faster. This move put the CPUs in second place in the computer hardware, because when you have a graphics card like GeForce 256, no matter what kind of CPU you have, your computer would always be more effective thanks to the graphics card. Well, this graphics card was also programmable, but we will talk about that in a minute. Now, we have to talk about Nvidia's journey from GPUs to government supercomputers. In 1999, Microsoft, who almost took out Nvidia out of business with DirectX, wanted to become partners with them for their next project, because at the time, Microsoft was in a bit trouble with this new gaming console called PlayStation. Sony's new gaming console was destroying the PC gaming craze, so Microsoft wanted a piece of the action in the console market and teamed up with the Nvidia to create Xbox. Xbox was released in 2001 and it was not a flop. It was actually pretty successful because it managed to pass all other gaming consoles in sales, but couldn't even manage to sell quarter of PlayStation 2. For Xbox, that was not a failure, but wasn't the success they were looking for. While Nvidia kept dominating the graphics market with accelerated GPUs, graphics in gaming industry was evolving in an incredible speed. With more possibilities, game creators started developing more complex and better looking games. Jensen's inventions were changing a whole industry, but he was about to change more. Sony would be the next partner for Nvidia to develop G70 graphics card for PlayStation 3. Console was released in 2006 and sold 87 million units. This time Xbox was right behind them with Xbox 360, sold 84 million units. But that wasn't the Nvidia's main concern. Do you remember when we mentioned that with GeForce 256, Nvidia made its graphics card programmable? Well, that means Nvidia's GPUs can be programmed and adapted by the applications outside of gaming. And with the release of PlayStation 3, Nvidia also released a programming interface called CUDA. It's a simple interface that used easy-learned programming language called C, opened the door for far more interesting use cases than gaming.
Molecular dynamics, seismic processing, CT reconstruction, image processing, a whole bunch of different things. Universities after another, researchers realized that by buying this gaming card called GeForce, you add it to your computer, you essentially have a personal supercomputer.
You could use Nvidia's graphics card for a bunch of different stuff, but perhaps the most interesting use case anybody ever saw came from US Air Force. In 2010, Air Force was in need of a supercomputer to use ultra-high resolution satellite imagery, but the computer they needed would cost $10 million to build with off-the-shelf parts. But PlayStation 3's graphics card G70 was amazingly energy efficient and was able to run third-party operating software. So US Air Force ordered 1,760 PlayStation 3s and created their own supercomputer that was able to process billion pixels per minute. For comparison, 4K images are 3,840 pixels by 2,160 pixels. But PlayStation 3's supercomputer, or also known as the Condor cluster, was able to process 31,623 pixels by 31,623 pixels. And thanks to Sony's pricing, the Condor cluster was made just under $2 million. But since Nvidia GPUs were so easy to reach and easy to program, possibilities were beyond Nvidia's control now. And soon they would discover a new horizon that would change the world. Andrew Ng, a quantum chemist from National Taiwan University. When he was teaching at Stanford, a couple of his students suggested him that they could use GPUs and CUDA to build a server and try to scale up their deep learning experiments. Andrew took that suggestion and they have built a server in one of his students' dorm room. And the results were amazing. They recorded that training neural networks with Nvidia GPUs was 100 times faster than any other method. But this was not the only case. Word got out fast and Geoffrey Hinton's lab in Toronto, Yan LeCun's lab in New York University, Andrew Ng from NTU, they all were doing the same thing and they all have reached out to Nvidia about what they were doing and to let them know about the new potential of their products. Jensen knew that there could be a new computing model he could create that would be far more impactful than the video games. Jensen had two options. He was either going to stay in the gaming industry, which he already dominated, and keep knocking heads against Intel or AMD, or he was going to spend billions in research and development for artificial intelligence. And keep in mind that Nvidia already went public and has a lot of investors that do not like spending millions in R&D for a market that don't even exist. They wanted Jensen to stay in his own lane and keep making money. But Jensen, in his own words, took a type of risk that unless you have survived the building a startup, you are allergic to doing, and started reaching out every AI researcher on the planet. He changed the direction of the whole company and without leaving the gaming GPUs, started developing the new ones that can compute larger data clusters for machine learning. And with every step of the way, they were seeing more and more people started adopting Nvidia GPUs for greater tasks. In just a couple of years, from large-scale data centers to cloud service providers started using them for day-to-day applications like healthcare and transportation. Nvidia's AI investment was proving itself quick, but Jensen would consider this still just the beginning of the research. Besides of him fueling the AI revolution, development speed itself brought Jensen Huang another great achievement. For the first 30 years, computer world was advancing in 10 times in every 5 years, but Nvidia managed to break the barrier of computer advancement.
We've advanced computing by about 1 million times, not 1,000 times, 1 million times. Not 100 times, 1 million times. And we're here now compounding at 1 million times every 10 years.
And this brings us to Huang's Law. Huang's Law provides us a speed that can help us solve the problems that we couldn't since the beginning of humanity.
And so the question is, what can you solve in the past that you were waiting for 1 million times to solve? A problem that you thought, I could solve this probably in about 30 years. Well, if you can solve it in about 30 years, you're probably going to solve it in 5. That's the big realization. That's groundbreaking.
Today, more than 1 million times better GPUs that were used by Air Force's supercomputers are being used in every industry you can think of. A young kid who was willing to teach how to read and write to his roommate just so he could help him survive a century-old war between rival families is now running the powerhouse of solutions to world's biggest and oldest problems.
You're zero and you're trying to become something more than that. The idea that you would be a global anything is insanely ambitious. By almost all measures, we shouldn't be here.